Hello and welcome to another free code session. My name is Jason Bach and I did some work this afternoon. It's a Sunday, so I spent some time this afternoon just being lazy, watching videos, doing some work on this, and I've made some progress, which is good. I also created a video because in the last video, you may have noticed that I was showing on my phone I was getting a phishing attempt. And so I decided to do a short video on that. I'll put a link in the description for anybody who wants to watch it. It's only 4 minutes long and it just kind of shows you what I found. I think if I did it again, I would kind of show here's what tipped me off. The link was a big one, but the wording and the message itself, how they were phrasing things, just something about, just things that just didn't look right. So I should have spent a little bit more time on that. And then also, how do you handle this in terms of, can you use tools to determine, is this URL safe or something like that? But in any event, I put that out there. Take a look at it if you want. So in this video, let's go through what I've done so far, which is pointer argument and pointer argument evaluation. I've got this all in from the code that I created before. And I've gone through with the void builder and the value builder for methods to change them so that they are using the pointer stuff, the pointer argument. Now, where is that? That's up here somewhere. That make that determination, right? I could just look for pointer argument in the current. There we go. So we don't have to worry about nullable with these. I did have to make one change, which is I need to know that the type is a pointer, but that's type kind of as a function pointer, because then we're going to go through all the special work that we're doing right now. Otherwise, I'm just going to do this. But I created a nullable type reference model here called pointer type, because I need to know what the fully qualified name is. So I did that and did that for the void builder as well, and things seem to work. I created a test that just has a method here. There's another test up here, I believe. There's one with get pointers and unmanaged function pointers. This one's a little bit more complicated, and it should, for these two cases, well, at least for this case, it shouldn't create the special type for the pointer anymore. It should for these though, because we have to. So that's what I'm going to do in this episode, is make sure that that happens. So let's run this test first and let's see if that happens. We also have to go into the indexer, because the indexer can take pointers as arguments. So we just got to make sure that we handle that as well. And then there was one other one here. You have the expectations. So these are the extension methods that you have to make sure have the right argument type. And I noticed in the previous attempt of this, I could actually see the commit in the branch. What I did, I never got actually into putting the pointer argument type in, but I did do some work to move things into an arguments namespace. If I can do the thing I think I can do with ref structs, specifically with spans, then I will do that, and I will put all the argument stuff into a separate namespace. But for now, I'm just going to leave it as is in any event. So we got to fix at least this test, and then we got to fix indexers. And then, of course, some other tests may break, though not a lot, because we don't do a lot with pointers. None of the integration tests should break, because that should just all work underneath the scenes. That shouldn't be any problem. And hopefully none of the code gen tests break either. So let's just see what the diff is on this one first. I would love for this window here to be just a little bit bigger, a little bit nicer. I've already talked about this, but So I believe the one I'm seeing here, yeah, you can pop it out, but that's not really what I want to do. So this is for, I believe, the delegate void and the delegate void. And then you still need to generate the pointer callback. That still needs to happen. You can't get away from it. The delegate pointer. Okay. And now you can see the argument, the delegate there and this one are gone. So, and yep, that's all gone. So we're getting rid of that. So let's actually go to where we just do that. get rid of the code because it's just easier to regen it and take all of what's there now. Let's grab all of this. And there's still stuff, fair amount being made, but that's fine. We just care about the fact that we do not get the generated code for the pointer argument anymore. That's the key. So grab that up here, go all the way up top. It would be nice if I could also not have to do the function delegate, because that would also get rid of some stuff, but you can only do so much. So here we have this one and delegate pointer. That's the handler information. Expectations extensions. Method dormants for delegate pointer. Method dormants for in pointer. Because there are reasons. I don't know why I do this. Yeah, that's interesting. Why do I do this? This would be a separate thing to the post-its. gotta write this down before I forget. And of course, I could just type this. But yeah, why? Let's type it, because I got all this stuff here. So to do. Why, when I gen a, what's this called? A method of dormants for in pointer. Well, why do I generate that at all? That doesn't make any sense, because we're giving the handler information for in pointer. That is arguments. I'm a little confused here. I don't really know why I'm doing everything that I'm doing here. Because I'm like, I'm kind of like, why do I do this at all? And in fact, why am I still generating these types? That one. That one. I'm not sure why those get generated at all. So, because that's this one, and this one should have a pointer argument cast. This one there's no argument, so it just returns and there. That's why. Okay, because reasons. I'm still not sure why you do this. Is it because this? I can see why you have to do it for this. This, I'm like, well, it's already unsafe. Why can't you just, and again, I just may be doing this because I'm doing it and I don't need to. Let me run this first. It does compile, but I think we need to do more work here. We need to say, can't I make pointer handler information and pointer method adornments? Because these need to be unsafe. That's the thing. They need to say that they're unsafe, which I guess you could just say use unsafe, but if you don't need to be unsafe, then don't use it. But the point is, you could take, this is the method adornment. We could take this thing here, and let's just go to the Sharp Labs. And here, you can see here is my check to say, yeah, you can still do that. That's fine. And of course, it's not going to know what some of these things are, but that's okay. Because what we really care about is, could we make this pointer handler information of T where T is unmanaged? And we don't care about this stuff right now. What we care about is just saying here T. And that's fine. So we could definitely do this. I just didn't put in that work. So we'll get to that before we do the indexers. So that's good. Let me commit. Okay, I'm going to assume that just all committed and we're good. So what's the order here? We did mock method, we did these. We did all of these. So let's actually put this here. And let's look for that. So I'm going to close all this. No, I want to be in here, and I want to say find this. So that makes sense, but we don't want to do this except where we need to. And it's all in here, which makes me wonder, well, I mean, yeah, it's nice that we can have a test here, but we really don't need that exposed anywhere. Get projected handler information, fully qualified name. That's that. But we really don't need to do this. But we don't need to do it here. We don't need to identify that it's something we need to build a type for. What we do need to do, though, is have that now in the code in the correct places. So we want to be a little bit careful here. But again, the thing is with all this, it's really, it's an edge case. All these are very much edge cases. They don't show up that much at all. I can't remember for the last time when I ever did build my own type that used pointers of any kind. But again, it's valid. You can do it. So this is a dormant name. These are the ones that actually build the types. So these are the ones we really want to look for where they're done, which is here, which makes sense because this is where we do build. So we would do mock projected types, build handler information, and a dormant type information. The thing is, I think we can always say in all these cases, is it a pointer and is the type kind of function pointer? Because then we have to do this. Otherwise we don't. But before we get too far ahead of us, let us remind ourselves that I need to go back down to the test here that I just did. Where is that? Projected types generator test. And yeah, this one. We want to now have a type like this, except we want it up here, and we're going to have pointer handler information of T. Pointer handler information of T, because that's such a good name. And we could actually put that in a separate namespace itself, but, and then we'll say unsafe seal class, and this derives from handler information. So now we have to, that returns a pointer value, creates a new this, the set of argument expectations, creates a new this, the validation delegate. And that's fine because if you give a custom delegate, that's still okay here. That's still fine. Though we could specify that delegate as a T delegate type, because then that actually would get rid of some casts. I don't know why I didn't do that, but oh well. And then here, it's that. And that's all we do. Why are you being, this takes the address of, gets the size of, or declares a pointer to a, wait, I thought, why is this, oh, forgot the where, T unmanaged. There we go. So now we don't have to generate that for these types. If we say is pointer and method return type kind, or type kind is equal to type kind function pointer. And we can do the same thing down here as well. And now we've got those in place. Property type. property type. Because you could have a function pointer as a property type. Weird, but you could do it. So now these are not created, but we also need the adornments for the methods, at least. We have method adornments like that. And if we look at our test, we do have something like this. Wait, where am I? Where am I? So we could have here a method adornments. No, not that one. We could say this is pointer method adornments. And this would be a pointer handler information. Now, what is the T here? Yeah, it can't be that T. It's got to be the type of the pointer. Wait, what did it do? Sometimes it does this where it's like, it does a copy. It doesn't actually, or did I, wait a minute, where? So you should be back to normal now. You should be back to normal now. Why are you not? This better be its own file. Yes, all this is gonna, that's right, because we have two of them, because we could have a callback on one of these. And you're all like, what is this? You're gonna tell me primary constructor, go away. This needs to be a pointer handler information. But of course, the T is a class where, why do we have T? Like, what's the point of T here? The mock type. Well, that's great. Oh, because we just pass that around everywhere. We don't, we should call it T mock is what we really should have done. Oh well, 8.0 is going to change everything. T pointer. So then we say here where T pointer is unmanaged, and this has to be an unsafe class, and this has to be that. Now you should shut up, but you don't. Why are you not shutting up? Well, that's fine. Oh, and now you are complaining because down here we need a T pointer where T pointer is unmanaged and handler information, pointer handler information. Oh, we didn't have one that has a, yeah, we need to, because if we go to argument, that has like argument and argument of T. This pointer, did we actually ever catch that? No, we didn't. That's a pointer argument evaluation. Wait a minute. Argument. There is a argument and an argument of T. Pointer argument. We have the pointer argument evaluation. We also have a pointer argument of T, but we need it to be T pointer, if that makes sense. Because reasons, this is starting to trickle in, and this is going to take time, and I might start doing some of this off camera because this is starting to get to a struggle point where all of these type parameters that are just called T, they're not clear. Like they should be T mock because it's the mock type. And if we just have T here, there's no meaning behind it, where we really want something to be the pointer. Like if you see, if you got argument here, we have just the base class. But where was I going with this? Adornments of handler information. So yes, if you have handler information, there is handler information where there is no return, handler information of T where there is a return. Aha. That's where we only need one here, because we can give it a call. Okay, I might be overthinking this a little bit. If we have to do a return, this is where the result would actually be the pointer. We don't need this because reasons. Now we need to say unsafe seal keyword. And we need to say here where T result is unmanaged. I don't think with the method adornments right now, if you look at the result, it doesn't, this is going to qualify. If you're going to take a method that doesn't return a pointer, you don't need to have this class, but this is only there if you have a method that returns a value that is a pointer. Pointer method does not implement method. What are you complaining about? Turns this. Cannot plus. Oh, yeah, that needs to be that. And then this is a pointer handler information. And that needs to be a pointer handler information. And there we go. So now we change that to that. Yeah, funny, we never return anything. T result. Return value. Oh, we need that to be a pointer. There. And simple. If you have a method that is not going to return something that is a pointer, you can just use method adornments, because that actually just has TNT callback. That's a delegate. You're just passing this around. You don't care about what it is. But if you want to set the return value, and I think that's what we have in the test here, is the fact that, well, we have method adornments, but we want to be able to say it returns this. That's the difference. So for the first test that we have, we wouldn't have that case. We wouldn't have, where is that one? The one I just added, pointers async. We just have this. What I think I want to do is something that says return get data, and say like int pointer get data, because we would also want to make sure that this is using our method adornments here. It's now using the pointer handler information that we just added. So now we have pointer argument, pointer handle, and I'm going to stop here because this is getting to be a little bit too much. I also need to put in here, before I forget, consider changing T to tmock to be more explicit with naming. And then we'll eventually get to the indexer stuff. There's always more. I might do these things off camera and get it to where I think I've got it. So then I can get rid of these two, and that would be nice. And we're going to be eliminating even more stuff, which is awesome. So I'll handle these off camera. And then I will come back in the next episode and we'll get the indexers all into place. Thank you all for watching. Leave comments and questions below. See you in the next episode.